again. In this video we learn how to multiply a number or a monomial by set of parentheses with something inside the parentheses, and so our final aim here is to understand what's going on here. We are not talking about division in this particular video, only about multiplication. So let us first consider some simpler examples. Let us begin with numbers. What if we have a expression? It might be written with a multiplication sign in this form, or it might be written in without, with another multiplication sign, another type, or it might be written without anything at all. All three forms are equivalent, and we have to, let me write it neater, 5 plus 7. So all three forms are equivalent, so I'll be using the shortest one. So you have to gradually get used to the absence of multiplication signs, like in 2x. Actually it is written 2 multiplied by x. So what do we do here? Of course, it's obvious. We use parentheses for changing the order of operation. We know that when we encounter multiplication and addition, first we perform multiplication, then we perform addition. But here, with a set of parentheses, the order is changed. First we have to perform addition and then multiplication. But our aim is different. We want to multiply out. We want to multiply this 2 by the set of parentheses in a different way. We want to remove the parentheses, and to do that we have to multiply this 2 by both expressions written inside parentheses. In case there are more expressions inside parentheses, you multiply the coefficient. We can call here factor 2 as a coefficient. We multiply to everything inside parentheses. So of course we don't draw those arrows all the time, but we draw them to understand what we have to do, and then you can mentally draw them, or just maybe in any other color, not in the red, not necessarily in the red. So we, in this case, we can't omit the multiplication sign, because otherwise it would be 25 and it would be confusing. And we multiply 2 by 7. What is the meaning of this operation? Why did we do that? Wouldn't it be easier to multiply, first to perform 5 plus 7, the addition, and then to multiply? Yes, of course, but it's an alternative way which sometimes gives us great benefits. When, for example, we multiply, let me give you an example. Let me multiply 7 by 17. How do I do that if I don't use long multiplication? I might proceed in the following way. I might represent 17 as 10 plus 7. So I perform the opposite operation. It is already done, the addition was already done. But why is it easier for me? If then I multiply out, I have 7 multiplied by 10 plus 7 multiplied by 7. This is exactly the multiplication table. This one is multiplication table 2, but it's a little bit easier. It's 70 plus 49. And even then I add in a different manner. I write 49 and 30 plus 19. Which gives me an opportunity to first add 70 plus 30 and then plus 19. It's 119. You would say, oh, it's nothing, I could do it mentally without those tricks. All right, let us multiply 7 by 217. In this case, it's longer. I would do the same. 7, 200 plus 10 plus 7. 7 can be easily multiplied by 200. And 7 by 2 is 14, and I add 2 zeros. Then here is 70. The second term is 70, and the third term is 49 again. And then we just add. We might add in the same manner like that, and we get 1519. I even had trouble reading this number. So in some cases those operations make sense, great sense. So here in my second example, I have already employed this process. So when I have more, as I mentioned it before, but didn't show anything. When I have more than 2 addends inside parentheses, I apply multiplication to both of them. The key here is to perform all multiplications, not to forget anything. We have to be ready to multiply with signs. What I mean is, for example, if we have 5 multiplied by a parenthesis in which we have such a thing. In this case, of course, it's easier to multiply first the addition inside parentheses. You get just 1, and we know the answer is 5. But let us multiply again, remove the parentheses, because this is the skill we are training here. 5 times negative 7, it's negative 35. And 5 times 8, 5 multiplied by 8 is positive 40. That is it. Actually, of course, the answer is 5 again, and it would be easier to perform the addition. But we're not after the addition. We're not looking only one way of performing this important operation. We have to understand both ways. Sometimes we'll be using addition inside the parentheses, but very often we'll have to perform those multiplications. We don't have any choice if the coefficient is multiplied by a parenthesis in which we have a polynomial. In this case, I can't perform the addition inside the parentheses, or in other words, it is already done. I can't simplify further what is written inside parentheses. The only thing I can do is to multiply out to remove the parentheses in the following way. First, I multiply 5 by x, getting 5x. And then I multiply 5 by 8, getting 40. That is it. That is my result. And it's exactly this last thing which we are after, because we are talking about monomials, about polynomials. Let us multiply from the book. I won't, this is the last time I draw the arrows. I won't forget, well, I would say I'll try not to forget when the multiplications are complex. Sometimes. Everybody forgets, but let's try not to forget. So 3a multiplied by a is 3a squared. 3a multiplied by negative 2. How do we do that? We take the coefficient 3 multiplied by negative 2, which gives us negative 6, and then we add the latter part. It's just a. That's it, our answer. Here there is another part of this same very task. We have to multiply 3a by a. It's again gives us 3a squared. And it's much easier to multiply coefficients in this case because we multiply 3 by 1, okay, getting 3, and plus 3a. Here in number 9, let us multiply 4c by c, which gives us 4c squared. And then c being multiplied by g gives us cd. Here, 2t's multiplied by r just gives us 2tr plus 2t times s. It's 2, we can write st, 2ts. So, let us look at more examples. Here, 5x is multiplied by 3x. Let's first multiply coefficients. We take 5 and 3, both positive, and multiplying them gives us 15. And then let's multiply the latter part. X multiplied by x gives us x squared. Then in the second multiplication we have to take the coefficient again 5, multiply it by negative 2, which gives me negative 10. It will be my coefficient for the next term, for the second term. And then I take the latter part, and this is x, just x. Here is another one. The first coefficient is 1. If it's not written here, it's always 1, positive 1. Positive 1 times negative 3 gives me negative 3. And then the latter part, x by x, x squared. And the second one, x multiplied by y, it's xy. Here we, again, I promised not to draw any arrows, but I can't resist the temptation. As Oscar Wilde used to say, I can resist everything but temptation. So, to stress, to underline that I have to multiply 4 by every member of what is written inside the parentheses of this polynomial. 4 by x squared, it's 4x squared. Then from 2x we take the coefficient 2 multiplied by 4, getting 8. The sign is positive, and latter part is x. And then 4 by negative 2, 4 multiplied by negative 2 gives us, sorry, I could save myself and write a plus and then a minus some negative sign, but I write negative 8 immediately. Here the same, 6 multiplied by y squared, 6y squared. Then 6 by 3, it's 18y. And then 6 times 2 gives me 12. In 12, first multiply coefficients. 2 multiplied by 3 is 6. Then latter part, a by multiplied by a is a squared, 6a squared, plus positive 8ab, plus 2ac. That's it. 2 times 3 gives me 6. R by r gives me squared, r squared. The second term is 8rs. And the last one is negative 6 and just r. Here in 13 now we have a negative coefficient in front of the monomial, in the monomial, which is in front of parentheses. No difference. Negative 2 times 3 it's negative 6 a squared. Then negative 2 times 4 it's negative 8 ab. And then negative 2 and ac. Same here. Negative 4 times 2, negative 8 x squared. Then negative 4 times negative 3, it gives me positive 12. Don't have to mess it up. And then xy, here x, here y. And then negative 4 by positive 2, negative 8 again. And xz, xz as we say in America. That is it. I hope after solving all those simple problems you understand what's demanded of us and where it is demanded in tests, in school exercises, and at high school and later at college. See you again soon.